All right, good afternoon. Okay, today I will show you how to solve problems in algebra using shortcuts and calculator techniques. So I will also um, be showing you, some of the techniques that will make the problem easier to solve. Let's try this problem first. So in this problem, we are going to solve for the least common denominator, least common multiple of numbers 15 and 27. So 15 and 27, so how are we going to do that? So to solve for the least common multiple, so all we have to do is to write down the numbers, okay, and their factors. Like for example, for 15, the factors are 3 and 5. For 27, the factors are 3 and 3 and 3. Notice now how I align the numbers. Okay, so if they have common factors, okay, you have to align them. If not, so you just have to skip it. Like for example, since 3 is common to both, I have aligned the numbers here. So later on, no, we will solve the LCM using this number. Okay, now let's go back here. Since 3 here is common, only 3 here is common, we call this as your GCF, or the greatest common factor. Or in some other references, they refer this as highest common factor. Okay, but for today, we will be solving only the LCM, least common multiple. So in here, the least common multiple can be solved using the factors. Okay? So here, 3 and 3 will count as 1. So 5, we have 1, 3, and another 3. So the LCM of the two numbers is just the product of 3, 5, 3, and 3. So let's try that using our calculator. So the product will be 3 times 5 times 3 times 3, we will have 135. So here, 135 will be the least common denominator. No, the least common multiple, I mean. Okay? Now, there's another way of solving this problem. Okay? I will show you how to solve this problem using a different approach. So I will clear this calculator first. And using the different approach, we are going to convert the two numbers into fraction by taking the sum of its reciprocals. So the sum of the reciprocals are 1 over 15 plus 1 over 27. Notice that 15 and 27 is converted to a fraction. Okay? So the result of this fraction will also be a fraction. Okay, this is your numerator and this is your denominator. So what we are after here is your denominator. Okay, the denominator in your fraction is actually your least common multiple. Least common multiple. So let's start. No? This time we will be using your calculator to solve the sum of the reciprocals here. So you can write that in your calculator as 15 raised to the power of negative 1 plus 27 raised to the power of negative 1. Press equal sign and look for the denominator. So in that case, the denominator is equivalent to 135. So therefore, your least common multiple is equal to 135. That's how easy to solve the LCM of multiple numbers using your calculator. Right, now we go to same problem, but this time we will be solving for the greatest common factor. So a while ago we have solved the greatest common factor. So again, let's review how to solve for the greatest common factor. So write down the numbers, their factors, and then look for the numbers common to both. So in that case, 3 is your greatest common factor. These numbers are common to both 15 and 27. Alright, so there's another way of solving GCF, or the greatest common factor. To solve for the GCF, just multiply the numbers. In this case, I will multiply 15 and 27. Okay, and then I will divide the product by the LCM. Okay, since the LCM is equal to 135, so 15 all over 135, the result will be, using your calculator, we have 15 times 27 divided by 135. The result will be 3. So 3 is the greatest common factor. Alright, so that's it for the greatest common factor. Now we go to the worded problem here. So let's try to solve the worded problem. Let me read the problem. Planets A, B, and C orbit a specific star once every 4, 8, and 21 months. If they are lined up now in the same straight line, what is the smallest number of months that must pass before they line up again? What do you think is the solution here? So this is a simple LCM problem. So the solution is using the least common multiple approach. So to solve this problem, we need to factor out the numbers 4, 8, and 21. Okay, so 4, the factor of 4 is 2 times 2. The factor of 8 is 2 times 2 times 2. And the factor of 21 is 3 times 7. Okay? So, as I have said a while ago, we need to line up factors that are common to the numbers. So in this case, we have here 2, we have 2, 2, 3, and 7. So this is now your least common multiple. LCM is equal to 2 times 2 times 2 times 3 times 7. That's the least common multiple. Let's try using your calculator. 2 times 2 times 2 is 8. 3 times 7 is 21. So that will become 168. So 168 is our least common multiple, or 168 months after the first alignment. Okay, they will line up again in 168 months. This will be our final answer. 168. All right. Now we go to laws of exponents. Now, laws of exponents is really simple, okay? Especially solving this type of problem. Now, when you solve this manually, since there are 3 variables, it will be time-consuming. Um, Especially if this problem is in your board examination problem, is part of the board exam problem. So what we will do here is to make this problem easier. Okay, so I will be focusing only on one variable, since this is a multiple choice exam. Okay, so meaning to say, for a multiple choice exam, the answer is always not in the choices. Okay? It's given that it is in the choices. Otherwise, if the answer is not there, so I believe the problem is that the problem should be a bonus problem. Now, in this method, I will be ignoring the rest of the variables. So I will be focusing only on the variable x. Okay, why variable x? Because from the choices, you can see here the variable x from the choices have different exponent, except for b and c, of course. So at least they have 3 distinct exponents. So we will choose that one. I will not choose y because y raised to negative 6 is present in 3 of the choices. So ignore that one. Let's just use x. Now to solve this one, we will use the laws of exponent, but for x only. So we have x squared. 2 times negative 3 is negative 6. Multiply that by x. No, negative 3 and negative 1 half is positive 3 halves. Divided by x raised to 5, negative 5 halves. So using the rule in laws of exponent, when you divide, you subtract the exponent. So when you multiply, you add the exponent. So therefore, this is now minus 6. Since that is multiplication, you will add the exponent. Minus, since that is division, you will subtract the exponent. That is what will be. If you want to use your calculator, go ahead. So this is negative 6. So plus 3 halves, okay, plus 5 halves. And again, plus 3 halves plus 5 halves. Alright, so the result will be negative 2. So as you can see here, okay, only this choice will be your answer, okay, because now it contains x raised to negative 2 as the power of as your terms in x. So meaning to say the rest will not be your answer. Okay? So I think this will be your answer. X raised to negative. So if you want to solve for y and z, go ahead. Okay? But in my case, this is the most simplest solution to this problem. Okay, now let's solve another one, the laws of exponent. So this time we are going to simplify this one. So simplifying this, is really easy. If you substitute a value, if you will change the value of a into something real, like for example, let's try, okay, a equals 0. Okay, let's try a equals 0. Take note, when you try a equals 0, a equals 0 should also be substituted to all of the choices here. So let's try to substitute a equals 0 to this one. This will become negative 1. A equals 0 to that number, that choice, that will become 8. A raised to 0, that is negative 7 raised to negative 2. This will become negative 1. 5 raised to negative 1. Okay? Then substitute this 0 to the expression here. Okay, let's try to substitute it. So for this expression, for that term, we have, since a is 0, that will become 49, right? That is 7 squared. That's 49 minus 8. What about this term? That will become 7 plus, what about this term? That will become 5 times 1. Okay? What about this term? Since a is 0, this is 1 over 7 squared. So 49 over 49 is just 1. So simplifying this one further, okay, this will be 49, this will be 56, this will be 6. Or shall we say this is 55 minus 56, which is equal to negative 1. So looking back at the choices, only one have the answer negative 1, which is choice letter A. So that will be your answer. That's how you solve the problem using substitution method. It's not that difficult. You can actually substitute that A equals 0 and calculate that in your mind. Let's have this problem. So this problem will be easier if we will convert all of this equation into the same equation of the same basis. Like for example, so for 27 and x over 27 raised to x equals to 9y, we can convert this to 3 raised to 3, that's 27 raised to x. Okay, this will be equal to 2, or this will be 3 raised to 2, that's 9 raised to y, right? Okay, so another equation, this one, this will become 3. So since this is 81, so 3 times 3 is 9, 9 times 9 is 81. So this is 3 raised to 4 y. Okay, multiplied by 3 raised to negative x is equals also to 243. And 243 is 81 times 3. Okay, 81 times 3 is 243. So that is 3 raised to the power of 5. Now, since they have the same base, we can actually equate their exponents. So in this case, now I will equate the exponent 3x now equals to 2y. That will be my first equation. But in this case, now I will equate this to 0 by transposing 2y to the other side of the equation. That becomes negative equals to 0. Okay? So in here, in this equation, I will rearrange that so that we have negative x plus 4y equals to 5. Take note, I just equate the exponents here. Okay? Now, using a calculator, you can use mode equation. You can use equation in your calculator. So go to your calculator, select mode, look for equation, that's 5. Okay, 5, and choose how many variables you want to, how many variables is present there. So in this case, now we have two equations, okay, equation 1 and equation 2. So we also have two variables. So we will select 1 here. So we will select 1. If now you will input all the coefficients here. So for the first equation, we have 3 as our coefficient for x. We have negative 2. And c is equal to 0. We have to input 0. Next, if we have negative 1, we have 4, and we have 5. Okay, then press equal sign. Then you have the value of x. So the value of x is equal to 1. Press enter again. Press equal sign again, so that your value y will be equal to 3 halves. So you have two values, you have two variables here, x and y, but we are just looking for the value of x. So the value of x will be x equals 1. So as shown here the choice A. That's it on how to solve the problem the easy way. Oh wait. Now before I go to the next problem, now I will show you another solution. So another solution that will, this is a long solution, but this technique will apply to any equations of two unknowns. Okay, equations of two unknowns. Now this will apply to any problem with two unknowns. Okay, I will erase this part first. So it is understood that the value 1 is the right answer. Now, I will be using another solution here. So this time, instead of um, creating two equations of x and y, I will just manipulate this. Okay? I will manipulate that equation and solve for the value of y. Okay? I will solve for the value of y here by manipulating this equation. So to solve for the value of y, we can just use the logarithm method. Okay? We can take the logarithm of both sides. That will become x ln of 27. That's the property of logarithm. We also have y ln of 9. Okay? So therefore, y is equals to x ln of 27 all over ln of 9. So this will be my first equation. So my second equation is here. So taking the logarithm of both sides, you will have y ln of 81. Okay, take note, this is multiplication, so it is addition. So in this case, this is addition, but the exponent is negative. So negative x ln of 3 equals to ln of 243. Take note, we took the logarithm of both sides, and then we will solve for y here. Therefore, y is equals to x ln of 3 plus, okay, take note, I transpose this, it becomes positive, plus 243 all over ln of 81. Now we have the value of y. So we have two values of y. So let's go here in our calculator and we will test now which value of x, no, in the choices that will make the value of y equal. Okay, so let's go to mode and then let's make our calculator back to normal. Mode 1. Okay. Now we will enter the equations here. The term I mean. So I have here x. We using colon notation. Okay. X. This is x ln of 27 divided by ln of 9. Take note guys, now you can actually use this in any problem using two equations and two unknowns. Okay, I will show you later on how to do that. Okay. This is my first term here. Okay. Now we will go to this term. What I'm going to do here is to separate the two problems using the colon notation. This is now x of x ln of 3, okay, plus ln of 243 all over, okay, all over ln of 81. Okay, take note, this is trial and error. What is important here is that when you substitute the value of x, okay, this value, if you substitute the value of x to the equation or to the expression in your calculator, the value of y should be equal. The goal is to find the value of x that will make the value of y equal. So let's start by using the calc function. So calc function will assign value to x. So let's try 4. Okay, 4, when x equals 4, the first equation will have the value of 6. The second equation will have the value of 9/4. So they are not equal. So meaning 4 is not the answer here. So 4 is not the answer. And then, again, we will use calc and then plug in 3. Let's try 3. So 9 halves. 9 halves, we have 2. So they are not equal as well. So this is now x. So meaning 3 is not the value of x. Again, we will try another value of x, 2. So that's 3 and 7/4. So this is not the answer. Okay? Since the value of y is different. So our goal is to make the value of y equal. So let's try 1. We already know that the answer is 1. So when x equals 1, the value of y is 3 halves. The value of y is also 3 halves in the other equation. So meaning to say the value of y are equal, so meaning to say x equal to 1 is the right answer. So let's see for the simultaneous equation using two variables. Okay, now let's try to simplify again this number. Okay, we've done this before. We substitute the variable by a number that will not make this expression or this equation with a denominator of 0. So what value of n, will not make this denominator 0? So I will try n equals to 0. Okay? When n equals to 0, then substitute the values here or 1. So n equals 0, this will become 4 times 5. Since n equals 0, that's 5 raised to 1. So 4 times 5 raised to 1 minus 10. And n equals 0, this is now 5 raised to negative 1. So 5 raised to negative 1 is just 1 over 5 all over 2 times 1. That's 2. So therefore, this is 20 minus 2 all over 2. So this is 18 divided by 2. The result will be 9. You can actually solve this using mental calculation. So this is 9 as your answer. Alright, so I have here another set of equations. Okay. So I have x plus y equals 50. Not x plus y, x times y equals 50, x times z equals to 10, and y times z equals to 20. Now, to solve this problem, we will be using this method. So I will be writing the equations here. Okay. X times z equals 10, y times z equals to 20. What I will do here is to multiply the three equations. When you multiply the three equations, okay, how many x do we have? So 2x, so that will become x squared, right? How many y? Y squared. How many z? Okay, that is when you multiply the three equations. So let's multiply the constant term. So 50 times 100 is 500 times 20. 500 times 20 is 10,000. Okay. Now we can actually reduce this to a simpler one by taking the square root of both sides of the equation. Let's take the square root. Square root of x squared is x. Square root of y squared is y. Square root of z squared is z. Square root of 10,000 is 100. But we are looking for the value of x. Okay? Since we are looking for the value of x, we need the value of yz. And in fact, yz is just over there, which is equal to 20. So therefore, the value of x is just 100 divided by 20, or equals to positive 5. It's here. It's 5. Okay. That is easy. So another way of solving this problem is using your calculator. So how are you going to do that? Because in your calculator, you don't have addition, or x plus y, or how many equations. It's multiplication. So from multiplication, we need to convert this to addition. Okay. So how are you going to do that? How do we convert multiplication to addition? So let's erase this first. Erase. Okay. So we know that the answer is 5, right? So now from the first equation, okay, from that equation, now we are going to take the logarithm of both sides. So the logarithm of xy will become ln x plus ln of y, which is equal to ln of 50. For the next equation, we have ln of x plus ln of z equals to ln of 10. From the next equation, we have ln of y plus ln of z equals to ln of 20. Okay, now we can use the calculator to solve the problems here. Okay, so let's try. Since in your calculator we don't have ln of x, it is good if we will substitute ln x by a. Let's say a is equals to ln x. So all ln x will be represented by a. All ln y will be represented by b. Okay, so now you have a plus b equals to ln of 50, and then a plus c equals to ln of 10. A of b plus c equals to ln of 20. Now we go to equations. Okay, mode in your calculator. Go to mode. Go to equation. That's number 5, and go to how many variables do we have? 3 variables. So select this one. Select these 2 or 3 variables. So take note of the arrangement. A plus b A plus C, B plus C. You are going to input the values, the coefficient of A. So the coefficient of A is 1, the coefficient of B is 1, the coefficient of C, since this is just A and B, is 0. Equal to what? ln of 50. ln of 50. For the next equation, we have 1 as the coefficient of A, 0 for B, 1 for C, and then ln of 10. Okay. Last equation, 0 for A, 1 for B, and 1 for C. And then ln of 20. Then press equal sign. Take note, we are looking for the value of x. Okay? So x is your A. So we will be solving for A. So press equal sign. So that is the value of your okay, this one. That's the value of your A. So A is A, no? A is equal to 1.609. Do not erase this in your calculator. Okay? Don't erase in your calculator. So since A is 1.609, we need to solve for the value of x. Okay? This is now equal to ln of x equals to your A, which is 6.09. To solve for x, we need to take the inverse natural logarithm of 1.609. So that is actually e raised to 1.609. Using your calculator, go to your calculator, press all clear, mode, let's say mode 1. Okay. Take note of your answer, 1.609. Go to shift ln, okay, not that one, shift ln, that is e raised to a certain number, raised to our answer. So answer is 1.609. Oh, this is wrong. Again, e raised to that number, and that is the value of x. So e raised to x. So x here is 1.609. So let's just input another value of 1.609. 1.609. I have not saved that in my calculator. Sorry for that. So this is approximately equal to 5. But in your calculator, that is equal to 5. So let's do that. No need to. The final answer here is 5. If you want, we can do that again. But try to do it on after this lecture. Okay, that's the value of which is 5. Okay, that's it for this problem. Now we go to our next problem. This time we are going to solve for the value of x here. Okay, the value of x can be solved, okay, using long method, but we will not do that here. I will show you the technique on how to solve this using your calculator only. So take note, if you will solve this, okay, let's try to solve this manually. To solve this manually, all you have to do is to take the square root of both sides. Take note, the square root of both sides. So square root of both sides, from this equation, this will become 3 minus 3x. Okay, I will just show you how time-consuming this problem is. So this is the square of that term. So the square of that is, the first term is 3 minus x, okay, plus 2 times this term and that term, that will become 2 square root of 3 minus x, square root of 4 minus 2x. Okay, I will erase this part first. Okay, so erase. Okay, I will erase this part first. Okay, plus square the last term, which is 4 minus 2x equals to 3 minus 3x. Again, you are going to combine, okay, all of them. After combining that, okay, again, you will be squaring the sides again. So that is time consuming. Okay. Now I will show you how to solve this the easy way. Okay. The easy way is to transpose this equation and this term, and we'll be transposing this term. We will transpose this term to the other side of the equation, leaving you 3 minus x square root of 3 minus x plus square root of 4 minus 2x minus square root of 3 minus 3x equals to 0. Now our goal here is what will be is to substitute the value of x. Okay? The goal is to find what value of x that will make this equation 0, or this expression 0. Now, you cannot simply substitute the numbers here in your calculator. Why? So, let's try this one. Let's try 4. If you substitute 4 to that term, that will give you an error in your calculator. Now, let's try that in your calculator. So using your calculator, you have to input, or you have to plug in, okay? Plug in the equation. So 3 minus alpha x, take note, plus square root of, okay? I will be using my mouse so that you will see my input. 4 times 2x minus square root of 3 minus 3 times x. Okay. Our goal is to find the value of x that will make this expression 0 using the calc function. Okay, take note, do not use shift solve here. Shift solve will only give you it will actually consume a lot of time solving a shift solve using shift solve. We will not do that now. Shift solve is not in my agenda for today. Okay? Alright. Now, let's substitute the value 4. Let's try 4. It will give you math error. So math error means, okay, so math error means the syntax is wrong. Like for example, you cannot take the square root of -1 using real numbers. Okay? So instead, we will be using complex. Okay? We are going to go to complex mode, mode 2. Okay, that's complex. Because we will be dealing later on with complex numbers here. And then input again your equation. 3 minus x. Take note, I am not using what we call this, shift solve. Later on, I will show you why shift solve is not advisable here. And shift solve is not the answer for all problems. It is time consuming. Okay, now we have the correct expression in complex mode. Now we can use 4 as the value of x. Okay, and the result is 0, right? Again, calc. Let's start with 1. Calc 1, the result is square root 2 square root 2, which is wrong. The answer should be 0. Okay? Again, press calc. Input 2. Okay, the answer is a complex number, which is wrong. Okay? Again, calc 3. The answer is still complex number, but when I use 4, the answer is 0. So our goal is 0, right? So 4 is the correct answer here. So take note of the technique I used. I did not use shift solve, or I did not use normal mode. So in this case, I use complex mode because of the square root function. Okay, now let's try to use shift solve. Let's see how many how time consuming is shift solve. So when using shift solve, you have to input the equations here. So normally, using shift solve, you will input this equation. That's right. Input the equation. 3 minus half x, okay, plus 4 square root of 4 minus 2x, okay, equal to equal square root of 3 minus 3x. Let's time. Let's time the value of this. Solve for x using shift. Okay, shift solve. Solve for x, assuming the value is 9. Okay, solve for x. You can't solve. Okay, you can't solve using shift solve. Right? So that is why shift solve is not advisable. Use calc in your calculator. Now we go to the next equation. So this time, you have to solve this problem. Take note, now we are dealing with radical signs here. So when dealing with radicals, you have to shift your calculator to complex mode. Mode 2, that's complex mode. And then later on, okay, you have to input the equation. So our goal is to find the value of x, so that the result will be equal to 9. I will not be transposing this anymore since this is just a constant. Our goal is to find the value of x that will result to 9. Okay? So we have 8 over square root of 3x, 3x minus 2. You can do that in your calculator. So using calc function, let's try 1. 1, the result is negative 7. So 1 is not the correct answer. Okay. Let's try letter D. 2, negative 2 over 55 equals. Okay, that will give you a complex number. This is also wrong. Okay. Again, calc function. Okay, this time I will have 136 divided by 243. And the result is a complex number also, which is also wrong. Now our last option is B, 163 over 240. The result is 9. There you go. The result is 9, so therefore this is the correct answer. That's the correct answer. So 163 over 243 is the correct answer. Alright. So we still have a lot of problems here. Now we go to the remainder theorem. So as you can see, okay, in the remainder theorem, okay, if, let's go back to the principle. If this function of x is divided by x minus a, this is x minus a, okay, the remainder is f of a. This is the remainder function of a. What does it mean? It means that the remainder, if this function is divided by that function, this is actually f of 2, okay, which is equal to 2 squared minus 4 times 2 plus 7. That's the remainder theorem. Okay, you can use that. You can solve that in your calculator. Let's go back to the computer mode, computation mode. So we have, you can input actually. You can input your equation, or you may just substitute. Okay. This time I will input my equation: x squared, okay, minus 4x, 4 times x, okay, plus 7, and then I will use calc function, okay, to solve for the remainder. This time I will plug in 2, and the remainder is equal to 3. So this is equivalent to 3. So the remainder here is 3. Okay. Now what about this one? We try to solve this one. Okay, since this is x cubed, I will write this as remainder of f of 2 or 3 halves. F of 3 halves is 4 times 3 halves cubed minus x times 3 halves squared minus 9 times 3 halves plus 7. Or you may use your calculator. All clear, we have 4 and x squared, x cubed, 4x cubed minus 8 x squared, 8 minus 9x. Make sure you have plugged in the correct terms. Like this one, is an error. Okay. Minus 9x. 9x plus 7. I think it's good. Then I will use cut. This time I will plug in 3 halves. 3 halves will become negative 11. So negative 11 is our remainder. That is the remainder in that. Else, okay, factoring. How do we factor this out? Okay, we can easily factor this by just substituting the value of b with a certain value so that it will be easier for us to factor this out. Let's try. So by inspection, you can say, let's try, or by inspection, since b here is the variable, we can say b, we will try b equals to 0. Okay, take note. So when b equals to 0, you will have 16 times negative 16 over 64. Now if you will do that in your calculator, you will have 16 times 16. Take note that it's negative. I will put a negative here. Okay, and I will divide this by 64. The result will be negative 4. Now if I'm going to substitute 0, okay, to b in the choices, the result should be negative 4. This is 4, this is negative 4, this is 3, this is 2. So therefore, the answer is this. So we don't need, okay, to solve this manually using factorization. All you need to do is just substitute a number. Okay, let's try another one. Can we just substitute a equals 0? Now let's try it. Okay, we will try. This time, we will use 0. So I will try. What happened to my? Okay, try of a equals 0. When a equals 0, what will happen to this? When a equals 0, this will become 9, right? A equals 0, this will become not 9, but 9b squared. Okay? The result should be 9b squared. So, this is 0, 0, 0, 0, 0, 0. Take note, this is the trial value of a. Let's see what will happen. We will eliminate some choices here. Okay? If we multiply negative b and negative 9b, the result will be 9b squared. And that is also correct. If we multiply this one and this one, the result is negative b squared. This is wrong. This is also wrong. This is also correct. But which one? Which of the two is the correct answer? Okay? Now, instead of trying the value of a equal to 0, let's try b. Let's try a equals to not 0. Or let's try a different approach. Let's say, I will erase this part first. Since we already know that there are two possible answers here. Okay? Only A and D are possible answers. Okay? Now let's try this one. Let's try the value of B. No, let's say the value of A and the value of B will be, both of them will be changed to a certain value. Let's say I will say B, A. What happened to my pen? Okay. Again, erase A. Let's try A. A equals 0.5, and then B equals, let's say, 1. Okay? So take note, we will just test this into choices A and D. Now, if we will use the calculator, okay, calculator, you can say alpha, let's say 4A, okay, squared. I don't know if you can still, you can use K. Let's say cal, oh, that's good. No, you can use A. Minus 20. Okay, alpha KB A alpha B, and then plus 9 B squared. Take note, this is the long method using this approach. You can easily factor this out. Okay. You can easily factor this out. Since this is just the value. So pulp, let's say pulp, A is 0.5, I will input A, B is 1. So the value is 0.5, B is 1, the value is 0. Okay. The value is 0, okay, take note, the value of this is 0 if A is 0.5 and B is 1. Now we will try it here. We will try it in the two equations. Okay. So this time I will not remove A and B. What happened here? Erase this part. So it will be clear. Okay, A is 0.5. Take note of that. Now let's just use this one. The answer should be 0. Okay. Let's try to get this one. Get this one. I will write it here. So when A equals 0.5, A is 0.5, this will be 1. B is 1, that's 1. This is 0. Okay? So meaning to say, no, by inspection, okay, the answer here is letter A. Letter A. Because it resulted to 1 minus 1, which is 0. If you will try to substitute that here, the result will not be 0. Okay? The result will just be 2 times 0.5, that's 1, plus 1, that's 2. So meaning to say this is a wrong answer. Now, there are a lot of solutions in solving this problem. Okay? Now, try to solve as many problems as you can and develop the best solution for this. Okay, now binomial theorem will be discussed in my next video. Thank you for listening to my solution. I hope you learned something using my technique and calculator techniques. Thank you and see you then.